Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is EdExcel June 2022, Paper 1, Higher Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Question 1, solve 7x minus 27 is less than 8. Okay, so this is an inequality that we need to solve. Now they actually just solve the same ways as equations. Now if we had the equation 7x minus 27 is equal to 8, then you should know that you kind of use inverse operations to simplify it. So for instance, if I add 27 to both sides, that's going to cancel with that, and it's just going to leave me with 7x on the left. And then 8 plus 27 is going to give me 35. Next step, divide both sides by 7. That will cancel with that. And then that leaves you with x. And then 35 divided by 7. That's 5. So I've got, if it's an equation, 7x minus 27 is equal to 8, then x would be equal to 5. But it's not an equation, it's an inequality. But as I say, they just solve the same way. So if I just replace all those equal signs with the less than or equal, a less than sign like that, then yeah, that's it. So x is less than 5. So just, you know, if you know how to solve an equation, then inequalities just solve the same way. Okay, so x is less than 5. Question 2, write 124 as a product of its prime factors. Now if this was the calculator paper, there's a handy button to do it, isn't it? You can just use the fact key, but this is not the calculator paper. So if it isn't a calculator, then you just need to keep thinking about pairs of numbers that give you that number and break it down slowly until you're left with prime factors. So can you think of two numbers that multiply together to give you 124? Well, if I halve 124, I'm going to get 62, aren't I? So I can say that 124 is 2 lots of 62. Okay, now 2 is prime, so I can't really go any further with that branch, but 62 is not. So I can break 62 down into what? Well, it's even again, so 2 divides it. So I could put 2 here, 2 is prime. 2 times 31. Now 31 is also prime, isn't it? You can't find any numbers that divide into 31. So then I can say that 124 then is equal to 2 times 2 times 31. The 3 leaves that we've got left. Question 3, a delivery company has a total of 160 cars and vans. The number of cars to the number of vans is in the ratio of 3 to 7. Each car and each van uses electricity or diesel or petrol. 1/8 of the cars use electricity, 25% of the cars use diesel, the rest of the cars use petrol. Work out the number of cars that use petrol. You must show all your work in. Right, so we've got quite a lot of things going on here, and it's about just going through carefully, step by step, and kind of breaking this problem down. Okay, now first off, let's start off with this ratio. I've got 160 cars in total, and I know that the number of cars to the number of vans is 3 to 7. Okay, so basically what I need to do is divide 160 in the ratio of 3 to 7. Now to divide a number by a ratio, we take the two parts of the ratio 3 to 7, we add them together. So 3 plus 7 is 10. Now that tells me that I've got 10 shares. So dividing 160 by 10, 160 divided by 10 means that each share is worth 16. Okay, so there's 16 cars in each share. Okay, so then if I take my ratio of 3 to 7 and I scale it up by a factor of 16 to make it 16 times bigger. Okay, so 3 lots of 16, that'd be 16, 32, 48, won't it? So 48 and 7 16s, what's that? So 10 sevens is 70, 6 sevens are 42, so that'd be 112 altogether, wouldn't it? So just double check your two numbers, add again to what you started with. 48 plus 112 does equal to 160, so that's looking good. Okay, so that means that there are 48 cars and 112 vans, because this was cars and this was vans, wasn't it? All right. Okay, so each car and each van uses electricity or diesel or petrol. 1/8 of the cars use electricity. Okay, so we've got 48 cars here, 48 cars, and then we know that 1/8 of them use electricity. So 1/8 of 48, that is 6 cars, isn't it? So 6 cars use electricity. Okay, 25% of the cars use diesel. So 25% of the cars use diesel. So I need to find 25% of 48. It's non-calculator, so 100% is 48. So no, half of that is 50%, and half of 48 is 24, and half of 50% is 25%, and half of 24 is 12. So I know that there are 12 cars that then use diesel. So we're getting there. Diesel. Can't spell diesel. Rest of the cars use petrol, so what's left? So then 48 minus those two, then 48 minus 6 plus 12. The remainder of the cars must be using petrol. So 6 plus 12 is 18. Take away from 48, that's 30 cars are petrol. Okay? So what's the question? Work out the number of cars that use petrol. It's going to be 30 then, isn't it? So 30 cars. Question 4a, write 1.63 times 10 to the minus 3 as an ordinary number. Okay, so I've got a number in standard form. It's a very small number because I've got a negative power of 10 there. And with these negative ones, all I do is, like, if it's a 3, then I write down 3 zeros, 0.00. So 1, 2, 3 zeros like that. And then I just write the digits of the number after it. So 163, 163, and that's my answer then. So because there's a 10 to the minus 3, they're going to be 3 zeros, 0.00, and then my digits 163. Okay, that's my answer. Part B, Part B says write 438,000 in standard form. Okay. Well, in standard form, it's going to have a mantissa part, which is a number rewritten in the value of between 1 and 10. So I've got 438 as my digits. I'm going to take those digits, 438, and rewrite it so it's a number between 1 and 10. So I've got to put the decimal point there. And then I need to work out what power of 10 that is. Okay, so if I'm going to move the decimal point from here to here, it's going to go 1, 2, 3, 4, 5 jumps to the left. So I make that 4.38 times 10 to the 5. Okay. Work out 4 times 10 to the 3 times 6 times 10 to the minus 5. Okay. Give your answer in standard form. Right. So when I've got 4 times 10 to the 3 times 6 times 10 to the minus 5, I can use the fact that multiplication is what we call commutative, and it means we can change the order that we do things. So rather than having the 4 there and the 6 there, I'm going to rewrite this so I've got like 4 times 6 at the front, and then I'm going to have my 2 powers of 10 at the end. So 4 times 6 times 10 to the 3 times 10 to the minus 5. Okay, and then I'm simply going to multiply those together. So 4 times 6, that gives me 24. And then I'm going to multiply the 10 to the 3 times the 10 to the minus 5. Okay, now using laws of indices, when I multiply numbers with the same base, I add the indices. So 3 plus negative 5, that gives me negative 2. So that's 24 times 10 to the negative 2. Right, that is not quite in standard form because 24 is not a number between 1 and 10. So I need to rewrite that as 2.4 times 10 times 10 to the minus 2. Okay, so that's another 10 to the 1, isn't it? And so 10 to the 1 times 10 to the minus 2, add the indices there. I'm going to get 10 to the minus 1. So my final answer is 2.4 times 10 to the minus 1. Question 5. Here is a regular hexagon and a regular pentagon. Work out the size of the angle marked X. You must show all your working. Okay, so here's X between the two polygons that they've been pushed together. Okay, now if I get a ruler out and I extend this line here where they meet, okay, a little bit. So just make this line a little bit longer. Now, this bit here, this part of X here, is actually what we call the exterior angle of the hexagon, isn't it? And this part here is equivalent to the exterior angle of the pentagon. Okay, now finding the exterior angles of polygons is really easy. All you got to do is divide 360 by the number of sides. So the exterior angle of the hexagon, that is going to be 360 divided by 6, which is 60 degrees. Okay, so that means that bit there is 60 degrees. And the exterior angle of the pentagon, that's just going to be 360 divided by the number of sides of the pentagon, which is 5, isn't it? So what's that? That's 72, isn't it? So that's 72 degrees. So that means that bit there is 72 degrees. And therefore, X is going to be the sum of those two angles. It's going to be those two added together. So 60 plus 72, that comes to 132 degrees. So that's my final answer, 132 degrees. Question 6a. Complete the table of values for y equals x squared minus 3x plus 1. Now again, if this was the calculated paper, we could just use the handy table function to work out this table in a jiffy, but we have to work them all out individually here. Okay, so I'm going to take each value of x in turn and I'm going to sub it into the function x squared minus 3x plus 1 and see what I get. So let's have a look at x equals minus 1 to start with. So when x equals minus 1, then x squared is going to be minus 1 squared minus 3 lots of minus 1 plus 1. All I'm doing is I'm taking minus 1 and I'm writing it there and there, aren't I? Okay, so I get minus 1 squared minus 3 lots of minus 1 plus 1. And I'm going to work out what that is. Okay, well, minus 1 all squared is positive 1 because a negative times negative is positive. Negative 3 times negative 1 is positive 3. And then I've got plus 1 on the end. So 1 plus 3 plus 1, that comes to 5, doesn't it? So that means when x is minus 1, then y is equal to 5. Okay? Right, let's take the next one. When x is 2. So when x is 2, when x is equal to 2, then I'm going to get 2 squared minus 3 lots of 2 plus 1. That's going to be 2 squared is 4. Minus 6 plus 1, and that's going to come to minus 1. Okay, when x is 3, what have I got? I've got 3 squared minus 3 lots of 3 plus 1. So 3 squared is 9. 9 minus 9, that's just going to be 1 in the end, isn't it? Because the 9s are going to cancel out. I'm just going to get 1. And then finally x is 4. So that's 1, that's minus 1. Then finally, when x is 4, I'm going to get 4 squared minus 3 lots of 4 plus 1. So 4 squared is 16, minus 12 is 4, plus 1 is 5. So that one there is 5 as well. Okay, so that's quite reassuring. You can kind of see that like these two match got -1 and -1, and then these two match got 1 and 1, and then these two match got 5 and 5. So you can see it's kind of symmetrical around here, which is what you kind of expect with a parabola, isn't it? You should have a kind of a low point on it, and then it kind of mirroring itself going back up the other ways. Part B says, on the graph, draw the graph of y equals x squared minus 3x plus 1 for the values of x from -1 to 4. So they're the same values that we just found in the table, aren't they? So our first value on the table was -1, 5. So we're going to have a point there. Then we had 0, 1. Then we had 1, -1. And then we had 2, -1. Then we had 3, 1. And then finally we had 4, 5. Okay, so they're the points that we needed to plot. We need to draw the graph though, so we're going to have to join those points up with a nice smooth curve. Okay, so we're going to have to draw a line that passes through each of those coordinates. Now it doesn't go flat along the bottom, it kind of dips down and then goes back up again like that. And then up through those points. Just take care that you skew each of the points that you plot, you don't miss, okay, and that you don't feather, so you shouldn't be doing double lines like that. And it should not be flat across the bottom, that's the other thing, it shouldn't be, okay, but I think that's all fine. Nicely drawn graph, Mr. T, thank you. Right, so then finally it says, using your graph, find the estimate for the solutions of the equation x squared minus 3x plus 1 is equal to 0. So remember we drew the line y is equal to x squared minus 3x plus 1, and the line y is equal to 0 is the x-axis, isn't it? That's the equation of the x-axis. So basically we're asking where the graph passes through the x-axis, and you can see that those points are here and here. Okay, so what are those values then? So that's going to be x equals what, 0.4? So x equals 0.4, or x equals, what's the other one, 2.6? Something like that, okay? So you just need to read off the value from your graph to the nearest little square, you'll be fine. Question 7, here are two cubes A and B. Cube A has a mass of 81 grams, and cube B has a mass of 128 grams. Work out the density of cube A to the density of cube B as a ratio. Give your answer in the form A to B, where A and B are integers. Okay, right, so let's have a look at this question. Now we're told that this one, A, has a mass of 81 grams. I'm just going to write it next to it so I can kind of visualize it all together. So that one's 81 grams, and this one has a mass of 128 grams. Okay, now I know that density is equal to mass divided by volume, isn't it? And I know the mass because I've been given that for both, but I don't yet know the volume, but I can easily work it out because it's just a cube, isn't it? So the volume of this one is just going to be 3 by 3 by 3, or 3 cubed, and 3 cubed is 27. And then the volume of this one is going to be 4 times 4 times 4, or 4 cubed, which is 64, isn't it? Okay, so then if density is mass divided by volume, then the density of A is going to be the mass of A, which is 81, divided by the volume of A, which is 27. 81 goes into 27. Well, I know that goes in 3 times. I'm used to cubing 3 and raising it to the power 4, so I know it must go in 3 times. So then, what's the unit of that? That's going to be grams per cubic centimetre. And then density of B, that's going to be the mass of B, which is 128, divided by the volume of B, which is 64. And 64 goes into 128 twice. So that's 2 grams per cubic centimetre. Okay, so we want the density of A to the density of B. So density A to the density of B written as a ratio. So density A is here, look, 3 grams per cubic centimetre, and density B is here, look, that's 2 grams. So that's just going to be 3 to 2, okay, as a ratio. Question 8, the table shows the amount of snow in centimetres that fell each day for 30 days. work out the estimate of the mean amount of snow per day. Okay, so when we're doing a mean from an estimated mean from a frequency table, easiest thing is to add 2 extra columns to the end. Okay, so we can put our numbers in. So I'm going to put like a line there and a line there for my 2 extra columns. Sometimes they're nice and they actually add the extra columns for you here, but if they don't, it doesn't take a minute to draw them in. And if you do draw them in, it just keeps all your work neat and easy to read and easy to, not just for the exam, but also for you when you're checking your work in. Okay, so I do recommend just taking a second or two to add that table nicely on the end. Right, so this is going to be mid-S, the mid value each of those groups, isn't it? So that's the first thing we need to do. So the first group goes from 0 to 10, and the midpoint of 0 to 10, 10 plus 0 divided by 2, that's 5, isn't it? 10 plus 20 is 30, divided by 2 is 15. 20 plus 30 is 50, divided by 2 is 25. 30 plus 40 is 70, divided by 2 is 35. 40 plus 50 is 90, divided by 2 is 45. So they're my mid values of each of those ranges. And then what we need to do is F times our mid-S then, don't we, to kind of work out a mean amount. It's a bit mean that they're doing this on the non-calc paper. We're going to have to do a lot of maths, aren't we? So 8 times 5, that's 40. 10 times 15, that's 150. 7 25s, that's 175. 2 35s, that's 70. And 3 45s, that's 135. Okay, so we need some totals now. We need the total frequency, sigma f. That's going to be the sum of that one. Now, I already know that, sigma f, it tells me here. So that adds up to 30. Now, the other one I need is sigma fs, which is the sum of that last column there. Okay, what's that then? So 0, 0, 5, 0, and 5, that adds up to 10. So that's 0 carry 1. 1, 4, that's 5, 10, 17, 24, 27. That's 7 carry 2. And then 2, 3, 4, 5. So that's 570. Okay, and then so the estimated mean is going to be our sigma fs value divided by our sigma f value, which is 570 divided by 30. Okay, so they can just cancel out, and as luck would have it, 3 does go into 57, doesn't it? So it goes in, what, 19 times? So that comes out to be 19. So that's our estimated mean. It's going to be 19 centimeters of snow. That's a lot of snow. Question 9. A cube is placed on top of a cuboid as shown in the diagram to form a solid. The cube has edges of length 4 centimeters. The cuboid has dimensions 7 by 6 by 5. Work out the total surface area of the solid. Okay. Now, if you were just working out the surface area of a cube, then you've got 6 faces, and each face has got an area of L squared, isn't it? So it would give you 6L squared. So that's going to be like the surface area of a whole cube here. But in this one, can you see that this face here is not on the surface? It's kind of covered. Those two, that's where the two cubes join. So that's not an exposed surface. So in this cube, you can only actually see 5 of the faces and not 6. Okay, there's only 5 of the faces exposed. So then the surface area of the cube part is going to be 5 lots of L squared, or 5 times 4 squared. So 5 lots of 16, that's 80, isn't it? So that's going to give me 80 centimeters squared. Now the cuboid would generally have a surface area. I should really say that's surface area, isn't it? So surface area is going to be, it's normally like you take each of the dimensions of the shape and you multiply them together. So like 5 times 6 plus 5 times 7 plus 6 times 7. So you take each combination of the of two sides and then you double it up because you've got matching faces at front and back, top and bottom, left and right. Okay, so that would normally be the surface area of a cuboid. The formula is 2 lots of LW plus LH plus WH, if that's one way of thinking about it. So I just sub the numbers in, but so that would give me, what's that, 5/6 is 30, plus 5/7, which is 35, plus 6/7, which is 42, doubled up. So what's that, well, let's add up the bracket first then. So 30 and 35 is 65, and 42 makes 107. Doubled up, 107, 214. So that's 214, okay? But again, like part of that top face up there is covered up. So you're only going to get this part exposed. So one of those faces has got a chunk out of it that's missing. And what chunk is missing? Well, it's just 4 times 4, isn't it? So I'm going to have to take off 4 squared off of each of these, which is take away 16, isn't it? So the surface area of the cuboid is going to be 214 minus 16, and that is going to be 198. So then the total surface area is going to be those two added together. The 80 contributed by the cube and the 188 from the cuboid give me a total of 278 centimeters in total. Okay. Question 10. The table shows some information about the profit made from each day at a cricket club on 100 days. Okay. So complete the cumulative frequency table from 0 to 50. Well, that's just this one here, isn't it? That's just 10. From 0 to 100, that's going to be 0 to 50, and 50 to 100 would be those two added together. So 10 plus 15, that's 25. The next one is going to be those 3 added together, or 25 plus the previous answer. That's going to be 50 altogether. The next one includes 30 as well. So add that on, I'm going to get 80. Then I add on 5, that's going to be 85. And finally add on 15. I get 100. Now just double check when you're doing cumulative frequency that the number here at the end, the last one, should match the total that you're expecting, and it does. So that makes me confident that I haven't made a mistake. Okay. Part B, on the grid below, draw your cumulative frequency graph for this information. Now when you're plotting a cumulative frequency graph, you plot upper class bound against frequency, cumulative frequency. So that point there, I need to plot 50 against 10. So 50 against 10. The next one, I'm going to plot in 100 against 25. So 100 against 25. Next one, I'm going to be plotting 150 against 50. 150 against 50, this is there, and so on. So then that'd be 200 against 80, there, and 250 against 85. So that's going to be halfway between those, and then finally 300 against 100. Okay, right, so you can also add an extra value. You can plot this one here as well. This is kind of like a bonus one. You can plot 0 against that left-hand value there. So I am going to have an extra point down here on the 0, 0 point. Okay, so once you've got all your points, again, you just need to join them up with a smooth curve passing through each of these. Now normally this is like an S-shaped curve, so it's got like an extra wiggle at the top for some reason. Goes more like that. Don't know why, that seems to be a bit of a low value there at 250. Okay, right, so then use your graph to find an estimate of the number of days on which the profit was less than 125. Okay, so we can find 125 on the axes. 125 is halfway between 100 and 150. So if I draw a line up from there, up to my graph, point, 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 and then turn around and go in this direction, then that will point to my answer. So what's that? That's 37. I make that about 37. So my graph says that's about 37. So less than 125 pounds, there would be 37 days that were at or less than 125 pounds. Okay. Use your graph to find an estimate of the interquartile range. So the interquartile range goes from 1/4 of the way through your data to 3/4 of the way through your data. So our graph here goes up to 100. So 1/4, so Q1 is going to be 1/4 of the way through, isn't it? It's going to be at 100 over 4. Now normally you add 1, but when it's large it doesn't really matter. It's going to be the 25th point there. So our lower quartile is going to be around about here. So let's draw that on. So if that's 100 and that's 150 and there's 10 divisions, then each one's going to be worth 5, isn't it? So that's 3 little boxes. Is that 2 little boxes up? So what's that, 110? So 25th value is going to be like 110. Okay, 110 pounds. Okay, that's Q1. Now Q3 is going to be at 3 lots of 100 over 4, so 3/4 of the way through the data set, around about the 75th value. Okay, normally we'd add 1 before we divide by 4, but again it's a large data set, so it doesn't really make a lot of difference in that scenario, so we just kind of miss it out in that case. All right, so I'm reading across from 75. So from 75 across to hit the graph and then down. Okay, so I make that like 2 little divisions down from 200, so that's 190. Okay. So then the interquartile range then is going to be the distance between Q1 and Q3 then, isn't it? So how far is it from 110 up to 190? Well, that's just going to be 190 take away 110. So the interquartile range is 80, isn't it? Okay, so that's my interquartile range, 80 pounds. Question 11. Cormac has some sweets in the bag. The sweets are lime flavoured or strawberry flavoured or orange flavoured. In the bag, the number of lime flavoured sweets to the number of strawberry flavoured sweets to the number of orange flavoured sweets is in the ratio of 9:4:x. Cormac is going to take at random a sweet from the bag. The probability that he takes a lime flavoured sweet is 3/7. Work out the value of x. Now I think we're going to do this one as a bit of a bar model because I think it will help you to visualize what's going on here. Okay, so if I just make like a bar with 2 layers, to represent all the sweets. Okay. So then I want to divide this bar up so that I've got the number of lime sweets, the number of strawberry sweets, and the number of orange sweets along it like that. So we're given that the probability that he takes a lime flavoured sweet is 3/7. Okay, so on our bar model, then the lime section is going to be 3 parts, and that means the not lime section, so the bit that's shared between strawberry and orange, is going to be 4 parts. Okay, like that. So 3 parts are going to be for lime and 4 parts are not lime. I don't know how they're going to split between the other 2 yet, but that's the lime section there. Okay, but up here, look, we're told that the ratio of lime to strawberry to orange, lime is 9 parts and strawberry is 4 parts, and the other one, orange, don't have orange, do I? Orange is x parts. Okay, So if this section here, the line parts, is 9, then each one of these is going to have to be worth 3, 3, 3, 3. And then all of these are going to have to be worth 3 as well, because they're all the same fraction. So that means that there must be 9 altogether for lime, and there must be 12 altogether to share between strawberry and orange. But we know there's going to be 4 strawberry, because it's given in the question up there. Look, so that's 4. So that means of those 12 that are remaining, so if 4 are strawberry, then the rest, which is going to be another 8, is going to be for orange. So that means there must be 8 over here, which are for orange. Okay? So that means for every 9 parts of lime, you're going to get 4 parts of strawberries and 8 parts of orange. So I'm going to say X is 8. Okay? Now there are other ways of doing this question, but I think bar models is often a very nice graphical and easy way of doing these sorts of questions that doesn't involve lots of algebra or complicated calculations. Just allows you to see everything in a kind of big picture and kind of reason it out without too much difficulty. Okay, let's move on. Question 12, express 0.117, which has got 2 dots on the 1 and the 7, so it's a recurring decimal, as a fraction. You must show all of your working. Okay, so I know a technique to do this. I let x equal to be my recurring decimal, which is 0.117, and the 1 and 7 repeat, don't they? So it's 1, 7, 1, 7, 1, 7, and so on. Okay? Now, if I times that by 100 and get 100x, then that is going to shift my numbers along by 2 decimal points. So rather than having 0.117171777, I'm going to shift it along 2 points. So I'm going to get 11.717171717, and so on. Okay? Now you can see that this part here, and this part here are identical. Okay, so if I subtract one from the other, okay, then this lot here is going to cancel with this lot here. Yeah, they're all like 7 take away 7 is 0, 1 take away 1 is 0, 7 take away 7 is 0, 1 take away 1 is 0. And so then, if I then just carry on to the bit that isn't quite the same, I'm going to get 1 take away 1 is 0, 7 take away 1 is 6, and I've got the decimal point, and 1 take away 0 is 1, and then 1 take away nothing is 1. So that gives me 11.6. Now, if I do the same subtraction on the other side, 100x take away x, that is 99x, isn't it? So I've got 99x equals 11.6. So if 99x is 11.6, then x is going to be 11.6 over 99, isn't it? Just dividing both sides through by 99. Now this is not quite a fraction, because 11.6, you can't have a decimal on a fraction. Okay, so I'm just going to times top and bottom by 10 to get rid of that decimal number. So that becomes like 116 over 990. Okay, now it doesn't say as a fraction in its lowest terms, so I'd probably bail out at that point. It doesn't say to cancel it down. So as long as you can get it as a fraction, don't feel obliged to cancel it down. Okay, I mean you could, but you wouldn't get any extra marks for it, and if you get it wrong, you'd lose marks. So either get the same marks or less marks for doing more work. What one are you going to do? Question 13. A right-angled triangle is formed by the diameters of 3 semicircular regions A, B, and C, as shown in the diagram. Show that the area of region A is equal to the area of region B plus the area of region C. Now, this is actually Pythagoras theorem in action. So you're probably aware of the formula c squared equals a squared plus b squared, because what Pythagoras stated was the square on the hypotenuse is equal to the sum of the squares on the other two sides, isn't it? So that's c squared, that's a squared, and that's b squared. And you should know that these two squares fit perfectly into this one, or at least you would if you had a decent math teacher who taught you it properly. So hopefully they did. Okay, so these two fit in there. Okay, exactly. But what you might not be aware of is actually there's nothing particularly special about squares on the sides of a triangle. You could actually put anything on the side of a triangle and the same would be true. So you could take the same right angled triangle, and instead of drawing squares on the side, you could draw equilateral triangles, and then you would find that this one plus this one fit exactly in there. Or, as you've got in this case, we've got semicircles, and it's just going to be an application of Pythagoras theorem, just the same way as squares, that these two areas fit exactly into this area up here. So like I say, you can draw any similar shape on the edges of these triangles and Pythagoras theorem would apply. Okay, we just kind of stick with squares because squares are easier to work with, but like I say, you can actually really do it with any shape at all. But they want to show it's true now. In this question, what we're doing is we're just going to prove that's true actually for semicircles, that the two smaller semicircles is going to give me the area of the bigger one. Okay. So how are we going to do that then? Well, what I'm going to need to do is I'm going to need to work out the areas of each of these things and show they're equivalent, aren't they? So I'm just going to use the fact I'm going to call this side here 2c. I'm going to call it 2c because it's easier than calling it c when I sub it into the formula. And I'm going to call this one 2b. Okay. So then if that's 2c and that's 2b, then this side here is going to have to be, using Pythagoras' theorem, it's going to be the root of 2b squared plus 2c squared, okay, which is the root of 4b squared plus 4c squared. Okay, now I can factorize out 4 out of those two and say that's 4 lots of b squared plus c squared, all rooted, and then I can break that root down into 2 and say root 4 is 2, and then I've therefore got the 2 lots of the root of b squared plus c squared. Okay, just simplifying that down a little bit. Okay, right, so that's the length of that line there. Okay, so we've got the 3 lines of the triangle given in terms of b and c. Okay, right, now the area of this small semicircle then is going to be half of pi r squared, isn't it? Because it's half of a circle. Now the reason I labelled it 2c rather than c is because I knew I wanted the radius and not a diameter. So I can easily half 2c and get c. So then the area of this shape is going to be a half of pi c squared. Okay, and then similarly this one is going to be half of pi b squared for the same reasons. Okay, and so then the combination of those two, so area b plus area c, that is going to be a half pi b squared plus a half pi c squared. I'm going to get rid of this diagram now because it's using up space that I don't need. I kind of was just using it as an explanation, not part of this problem, and I need the space. Right, okay, so that's the area of b plus the area of c. Now I need to show that's the same as the area of a. So in order to do that, I need to work out what the area of a is. Area of a now that is going to be, well, I worked out the length of that side was 2 lots of b squared plus c squared. So it's going to be, again, half of pi r squared. Now this time my r is going to be b squared plus c squared, isn't it, from up there? So it's going to be a half of pi root b squared plus c squared squared. Okay, so when you square root a square, you're just going to get your thing back again, then, isn't it? So like that square root and square cancel each other out, and I'm left with a half pi b squared plus c squared. Okay? Now, if you compare that with what I got up here, I had half pi b squared plus a half pi c squared. Now, if I factorize out the half pi, then I've got the same thing, haven't I? I've got b squared plus c squared. Okay? So I think I've kind of shown it there. So if you think about it, I started off looking for area B, which was this one. Okay, I might change the color so it's a bit clearer. And then I worked out the area of C, which was this one here, and that gave me this and this, okay, which then gave me that thing at the end. And then I worked out the area of A, which was this, and then I've shown that those two things are the same thing. Okay, so I've kind of proved it. So I can therefore say that area A equals area B plus area C. Okay, well, that was not very nice, was it? Question 14, here is a speed time graph. Yes, it is. Work out and estimate the gradient of the graph at t equals 2. Okay, so where is t equals 2? T equals 2 is here on the axes. So if I read up from there until I hit the graph, then that will be the point where I need to take my tangent, and isn't it? So where's that then? It's here, this point there. Okay, so that point. Now to find the tangent, what we do is we kind of push our ruler up against it. So at the point of contact, so like the kind of space like over here is the same as the space over there. So that seems to be about right. So I'm gonna draw the tangent on now. Okay, so it should just touch your curve at the point of contact and have the kind of similar amount of space either side like that. All right, and then we need to work out the gradient of that line and then use that as an estimate of the gradient of the actual shape. Okay, so I'm going to take points that I can easily read off this graph and work out like change in y divided by change in x. Okay, so I think I'm going to start at 0 and go up to 4. That makes sense. So if you have a look at the triangle, if I draw a triangle from where that gradient is at time 0, there, look, it's kind of like 4 squares up. Let's just make a little triangle here then. So if I go along from there until I get to 4, and then change direction and go up, then if I can find the change in y and divide it by the change in x, then I'll get the gradient of this tangent, and we can assume that's the same as the gradient of the curve at that point. Okay, so the change in y then, that point up there, that's 4.8, isn't it? So that's going to be 4.8 minus, what's it at the bottom? 0.8. Okay, so that gives it a height of 4. And in the other direction, it goes from 4 to 0, doesn't it? So 4 minus 0 is 4. So the change in y is 4, and the change in x is 4. So then the gradient equals change in y divided by change in x is going to be 4.8 minus 0.8 divided by 4 minus 0, which is 4 divided by 4, which is 1. So it has a gradient of 1. So when t is 2, the gradient is 1. Now, what does the area under the graph represent? Well, area under a speed time or velocity time graph is equal to the distance travelled. Okay, distance travelled. Okay, that's what it's equal to. Question 15. A, B, and C are 3 points such that the vector A to B is equal to 3A plus 4B, and the vector A to C is equal to 15A plus 20B. Prove that A, B, and C lie in a straight line. Okay, So we've got 3 points A, B, and C, and mathematically what we want to do here is to show that the 3 points are collinear. In other words, they lie in a straight line. Okay, so I've got the point A, and I've given a vector from A to B, and I've also been given a vector from A to C, and I want to show that actually B lies on the line AC then, don't I? That's kind of what I want to show. So it's not like that, it's more like that. A, B, and C. Now to do that, all I need to do really is show that one vector is a multiple, a scalar multiple of the other one. Because if they are, then they have the same direction, they're just one is slightly longer than the other. Okay, so can I easily do that? Well, I think we probably can, because if I look at the vector AC, which is equal to 15A plus 20B, I can see that 15 and 20 have got a common factor of 5. So if I factorize that out, I'm going to get 5 lots of 3A plus 4B. And 3A plus 4B is the same thing as vector A to B then, isn't it? So that is equal to 5 lots of the vector A to B. Okay, so I've shown that AC is a multiple of the vector A to B. It's 5 lots of it, and therefore because they share a point they must be collinear. So as AC is a scalar multiple of AB, they must be collinear, which means they lie in a straight line. Okay, now moving on, D, E, and F are 3 points on a straight line such that the vector D to E is 3E plus 6F, and E to F is the vector minus 10.5E minus 21F. Find the ratio of the length of DF to the length of DE. Now, first up, just notice that we've got a different vector here than the two that have been given us. It's actually asking me for DF here, and I don't have DF at the moment. I've got D to E, and I've got E to F. So the first thing we're going to need to do is to find out what DF is to start with. So what is D to F? D to F is going to be the same thing as the vector D to E plus the vector E to F. Okay, because if we've got 3 points, D, E, and F, and I want to know the vector D to F, then that is going to be the vector D to E plus the vector E to F, isn't it? Okay, so that kind of makes sense. All right, so that means I can add those two vectors together I've been given it, which is 3E plus 6F for DE plus negative 10.5E minus 21F. For that's EF, isn't it? Okay, so I've just taken the vector DE that I was given here and written it here, and I've taken the vector EF that I've been given here and writing it here. Now I'm going to add those together and make one vector, DF. So I've got 3E take away so I've got 3E take away 10.5E. That's going to give me minus 7.5E. And I've got 6F take away 21F. That's going to give me negative 15F then, aren't I? Okay, so DF is minus 7.5E minus 15F. Now if I compare the vectors then together, let's just write DE over here next to it so I can compare them. So DE was 3E plus 6F, okay? So matching up the parts with the parts, can you see like the ratio of E to DF to DE is going to be this one to this one, or it could be this one to this one, but actually they're going to end up being the same thing, I think. Now one of these is negative and one of these is positive, but I'm just really interested in the length. So whilst lengths with vectors are directional, if I just want to find the ratio of the lengths, I think I can just ignore the negative signs on the DF one. And if you think about it, then this one up here is scaled up by a factor of 2.5. So if I multiply dE by 2.5, or negative 2.5, I guess, I would get vector df, wouldn't I? Okay, because 3 times 2.5 is going to be 7.5, and 6 times 2.5 is going to be 15. Okay, so then the ratio of the length of df to dE is going to be, well, it's going to be 2.5 times as much, isn't it? So it's 2.5 to 1, I guess. 2.5 to 1, which I suppose is the same thing as 5 to 2. Okay? Question 16. A first aid test has 2 parts, a theory test and a practical test. The probability of passing the theory test is 0.75. The probability of passing only one of the 2 parts is 0.36. The 2 events are independent. Work out the probability of passing the practical test. Okay. Now, if you imagine this was a tree diagram, so you would have like passing the practical test or not passing the practical test, and passing the theory test and not passing the theory test. That would be like what the tree would look like, isn't it? Okay. Now we know the probability of passing the theory test is 0.75 because we're given it in the question. Okay, so then that'd be 0.25, and that'd be 0.75, and that'd be 0.25, wouldn't it? Okay, and then we know that the probability of passing only one of the 2 parts is 0.36. So only passing one of the 2 parts would be this, or it would be this. Okay, so what we'd need to know, or what we would then say, that the probability of passing the practical but not passing the theory would be that one, and this would be the probability of not passing the practical but passing the theory. Okay, and whatever those 2 were, then the probability of just passing one of them would be those 2 added together, then wouldn't it be the probability of the practical not theory plus the probability of not practical theory, like that. Okay, so what do we know about this? Okay, well, we know that altogether that has got to be 0.36. Okay, but we don't know what this part is, so let's give it an algebraic value. So if I said that this part here was x, the probability of passing the practical was x, then the probability of not passing the practical is going to be 1 minus x, isn't it? Okay, and because the 2 things add up to 1. So then the probability of passing the practical but not the theory is going to be x times 0.25, which is just 0.25x. Okay, and then the probability of not passing the practical and then passing the theory is going to be 1 minus x times 0.75, which would be 0.75 minus 0.75x, multiplying out the bracket. Okay, and so I can then add those into this and kind of form an equation in x to solve then, can't I? So if I just sub those 2 values in, look, because I've got this one here, which I can sub in for that, and I've got this one here, which I can sub in for that. Okay, so that's going to be probability of practical not theory, that was 0.25x, and the probability of not practical theory was 0.75 minus 0.75x, and that is equal to 0.36. Okay, so let's collect like terms then. I've got 0.25x minus 0.75x, that's going to give me minus 0.5x plus 0.75 is equal to 0.36. I think I'm going to collect the x's on the opposite side to make it positive. So I'm going to move that one over there, it's going to become positive, and I'm going to subtract this, move it this side, collect the numbers on the left and the x's on the right. So that's going to give me 0.5x is equal to 0.75 minus 0.36, which is, what's that, 0.69, 0.39, isn't it? So that's equal to 0.39. So the probability, so x, half of x is 0.39, so then x is going to be double that then, isn't it? Doubling it up, that's going to be 0.78. Okay, that's my value of x. So work out the probability of passing the practical test. So let's just write that down. Probability passing practical is going to be 0.78, and that's our answer. Okay. Question 17. Y is directly proportional to the square root of t, and we're told that y equals 15 when t is 9. And then we're told that t is inversely proportional to the cube of x, and that t is 8 when x is 2. Find the formula for y in terms of x. Give your answer in its simplest form. Okay, so we've got a bit of work to do here. So this first statement is giving me the relationship between y and t. Okay, and this second one is giving me the relationship between t and x. Okay, so I'm going to get, the first one's going to give me an equation in y and t, and the second one's going to give me an equation in t and x, and then I'm going to have to solve those simultaneously, or kind of piece them together, so I can replace t in both and just get an equation in y and x. Okay, right, so let's start with the first statement. Y is directly proportional to the square root of t. Now mathematically we would write that down as y equal fishy root t. Okay, y is proportional to the root of t. Okay, then we can replace that little fishy symbol of proportionality with y equals k, and then lots of root t like that. Okay, and then we can take the two values that gives us when y is 15, t is 9, to sub those into the equation. So when y is 15, t is 9, that tells me then that I get 15 is equal to k lots of root 9. Well, the root of 9 is 3, so I get 3k is equal to 15, and then dividing both sides by 3, I'm going to get k is equal to 5. Okay, so then I can piece it together and say therefore y is equal to 5 lots of root t. Okay, so I've got my equation in y and t. Okay, so in the first part. The next part is to do the same thing but for t and x. I'm told that t is inversely proportional to the cube of x, so t is proportional to 1 over x cubed. Okay, so then replacing the symbol of proportionality with equals k, I'm going to get t equals k over x cubed like that. Okay, we know that when t is 8, x is 2. So when t is 8, x is 2, that's going to give me 8 is equal to k over 2 cubed. Well, 2 cubed is 8. 8 times 8 is 64. So that tells me that k is 64, and therefore t is equal to 64 over x cubed. Okay, so now I've got two equations. I've got an equation in y and t and an equation in t and x. Oh, they don't fit together so nicely, do they? Let's have a think about this. How can I sub one into the other? Okay, well I guess we've got t embedded in this one here, haven't we? And then I can probably just replace it with this, and hopefully it all kind of shakes out in the wash. Let's call this one equation 1, this one equation 2, and say substituting equation 2 into equation 1, what we're going to get? We're going to get y is equal to 5 lots of the root of 64 over x cubed. Okay? Right, so when you apply a root over a fraction like that, you can root top and bottom separately, can't you? So you can say that's the same thing as 5 times the root of 64 divided by the root of x cubed. Okay, well the root of 64 is just 8, so that's equal to 5 times 8, and that is going to be over well, what's the cube root of, sorry, the square root of x cubed? That's going to be x to the power of 3 over 2, then it's just a simple index. So 5 times 8 is 40. Now I could either write that as x to the minus 3 over 2, or I could leave it as a 40 over x to the power of 3 over 2. It doesn't really matter. I think I'm going to write mine like that. Okay, so that's my final answer. It's going to be 40x to the power of negative 3 over 2. Okay, I think part of it's fallen off the screen. I'm just going to move it over so you can see the full solution. Question 18. Work out the value of 5 4/9 to the power of negative a half times 4 2/3 all over 2 to the minus 3. Okay, well this looks like a bunch of fun. Let's start by rewriting things as top-heavy fractions, because mixed numbers like that don't really work very well for me. So let's do that. So 5 4/9. I know that 5 times 9 is 45. So add 4 on top. That's going to be 49 over 9, isn't it? So I've got 49 ninths to the power of minus a half multiplied by 4 2/3, doing the same thing. 4 times 3 is 12. Add on the 2 is 14 then, isn't it? So that's 14 over 3 for that fraction. And I might just do that power down there. 2 to the minus 3. That's interesting. So I think what I might do is I might just show that as a division. So rather than write it down there, I'm going to write it as a division over here, because that minus power there is going to be a bit confusing, because it's going to have to flip over. And if it was on the bottom, it'd have to flip onto the top, which is a little bit confusing. So I'm going to write it down there as division, and I'll show you what happens in a sec on the next line. All right. So then taking something and raising it to the power of negative a half, where if it's a negative index, that's the same thing as 1 over the positive version of that index. So that would be flipping that fraction over. 49 over 9 to the power of negative half becomes 9 over 49 to the power of positive half, times 14 over 3. Not changing that one at the moment. And then I'm dividing by, what am I dividing by? 2 to the minus 3. So a negative index means 1 over the positive version of that index. So it's going to be like that. Okay. And then let's kind of trundle on. Applying that power of a half, when you've got an index over a fraction like this, it actually gets applied to both parts of the fraction, the numerator and the denominator. So power half means the square root. So the square root of 9 is 3, and the square root of 49 is 7. So I get 3/7 times 14 over 3. And then dividing by a fraction, keep, change, flip. So keep the first part, change the divide into a times, and flip the fraction over, so it becomes that. Okay, which I think I'm going to rewrite as an 8, because 2 to the power 3 is just 8. Okay, so I'm just going to replace that with an 8 now. Okay, right, then we just got some fractions to multiply through. Before I do, I just spot I've got a 7 there and a 14 there. So I'm going to just cancel those out. And I've got a 3 there and a 3 there, so I'm going to cancel those out as well. So I end up with 1 times 2 times 8 on the top. 1 times 2 times 8, that's 16, over 1 times 1, which is just 1. So it's 16 over 1, or just 16. So that's my answer. The answer is 16. Okay, so it came out nice in the end. Question 19. Solve 1 over 2x minus 1 plus 3 over x minus 1 is equal to 1. Give your answer in the form p plus or minus root q over 2, where p and q are integers. Okay, well, this bit here looks a bit like the solution of a quadratic formula, doesn't it? So I imagine what we're going to do here is we're going to take this these algebraic fractions, we're going to combine them in a way together, and that's going to give me some sort of quadratic that I can then go on to solve, and then I'm going to get an answer a bit like that. Okay, so that's the plan. Let's see if we can make that plan a reality. Okay, so first thing, let's try and get these algebraic fractions over one common denominator. So what's common out of 2x minus 1 and x minus 1? That's going to be 2x minus 1 times x minus 1. Okay, and then what happens is we've got 2x minus 1 goes into 2x minus 1, x minus 1, x minus 1 times. So we're going to multiply those together on the left at the top. So I'm going to get one lot of x minus 1, or just x minus 1 up here. And I'm going to get plus, and then x minus 1 goes into 2x minus 1, 2x minus 1 times. So that means I end up multiplying those together, and that goes on the other side of my fraction. So I'm going to get 3 lots of 2x minus 1 over here. Okay? Right, and that's equal to 1. Now what I can do is I can just multiply through by this bit on the bottom, and it will end up moving up there. Okay? So multiplying both sides through by 2x minus 1, x minus 1, I'm going to get x minus 1. Just going to multiply out the numerator as I go through. X minus 1, removing this bracket here, I'm going to get 6x minus 3, and that is going to be equal to 2x minus 1, x minus 1 over here. Okay, so I'm going to collect like terms on the left. I've got x and 6x, that's going to give me 7x, and I've got minus 3 and minus 1, which is going to give me minus 4. And on the other side I'm going to multiply out the brackets. I'm going to use FOIL over here. So first outside, inside, last, or 2 eyebrows, a nose and a mouth, and that's going to give me 2x squared minus x minus 2x plus 1. Okay, just collecting like terms there. I think I'm going to collect everything on the right hand side. Well, okay, well let's just tie this up first and then we'll do that. Otherwise I don't want to confuse people. So I'm just going to tie that up and say that's equal to 7x minus 4. And then I'm going to collect everything on the right hand side and make it equal to 0 on the left hand side. Okay, so I've got everything on one side. So the 7x on the left, when it moves over, it's going to become minus 7x. So minus 3x, take away 7x is minus 10x. And I've got a positive 1, and when I move that minus 4 over, it's going to become positive 4. So plus 1 plus 4 gives me plus 5. Okay, so I've got 2x squared minus 10x plus 5 is equal to 0. So now I can use the formula, can't I? Okay, a is going to be equal to 2, b is minus 10, and c is 5 from use of formula. And I know that with the formula, x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so subbing in my values from a, b, and c then, that's going to be minus negative 10 plus or minus b squared, negative 10 squared minus 4 times 2 times 5, just subbing in a, b, and c all over 2 lots of 2. Okay, just need to tidy that up now. So negative 10, that's positive 10, plus or minus, well, I've got minus 10 squared, that's 100, isn't it? So that's 100 minus 4 times 2 times 5, 8 5s are 40, so that's 100 minus 40 over 4. Okay, so what's that then? That's 10 plus or minus root 60 over 4. Okay, now it's not quite what I need here, because I need a 2 on the bottom and I've got a 4 on the bottom. Now I can factorise out a 10 out of the 2 out of the 10, but I need to be able to do the same thing with the root 60 if I'm going to make it into that form. But 60 has got a square factor, isn't it? If you think about it, 60 is 4 times 15. So I can rewrite, so I can rewrite that as 10 lots of 10 plus or minus 2 root 15 over 4. Okay, and then I can kind of factorize the 2 out of the 10 and the 2 root 15, divide it into the 4. Okay, and then that will give me what I need. So let's just do that. So that's 2 lots of 5 plus or minus root 15, okay, over 4. And so then that cancels with that, leaving me with a 2 on the bottom. And then the final thing I'm going to get then is 5 plus or minus root 15 over 2 as required. Okay, so it is the form of p plus or minus root q over 2 as we needed to get it to be. Okay. Question 20, the center of a circle is the point with coordinates minus 1, 3. The point A with the coordinate 6a lies on the circle. Find the equation of the tangent to the circle at A. Give your answer in the form ax plus by plus c is equal to 0, where a, b, and c are integers. Now, this is a very wordy question, and you know, I have no idea what's going on right now. I need a picture. Okay, if you need a picture too, really. I don't believe that you don't. So I think with these sorts of questions where you got lots of wordy stuff and it's actually like coordinate geometry, you need a sketch. You need to kind of get it down as a picture to kind of fully appreciate what's going on. Okay, so we're going to draw it out then. So center of a circle is the point with coordinates minus 1, 3. Now I'm going to start off by drawing a circle because I think it's easier to fit the axes to the circle than it is to fit the circle to the axes. So I kind of just sketch a circle. I'm cheating a little bit, but you know, you just have to kind of freehand it or use a compass. So there we go. That's going to be the center, and that's at minus 1, 3. So where the axis is going to be? Okay, so minus 1, 3 is in the second quadrant, isn't it? So I'm going to have the y-axis going slightly to the right, and I'm going to have the x-axis kind of below it there. Okay, so minus 1 along minus 1 up 3 is in about the right place. Okay, and then we've got a point on the circle over here maybe, which has coordinates 6, 8. Okay, so find the equation of the tangent to the circle at A. Okay, so that's the point A up there, isn't it? We want the tangent to the circle, so a tangent is a line just touching the circle at the point of contact. So my tangent is going to be down here, somewhere along there somewhere. Okay, we need to find the equation of that line. Okay, now I do know that a radius and a tangent are at right angles, aren't they? So I can use my circle theorems to help me here. Okay, so I know that needs to be that is a right angle. Okay, so that gives me a bit of a plan then. Okay, if I can work out the gradient of the red line, okay, using the 2 points that I know, the end of the center of the circle and the point A, I should be able to find the gradient of OA. And then because I know it's at right angles to the tangent, I can then find the gradient of the tangent using m1, m2 equals minus 1. And then once I know the gradient of the tangent, I know a point it passes through, so I should be able to find its equation. Okay, so I've got a plan now, and I didn't until I drew the sketch. So draw the sketch. Right, so I'm gonna find the gradient of OA first. Okay, gradient of OA. So how do we find the gradient of line given 2 points? Well, we've got that formula, don't we? We've got gradient is y2 minus y1 over x2 minus x1. Okay, so that's what I'm going to use here. So I'm going to say that this one is x1 y1 and this one is x2 y2 to find that gradient and sub it into this then. So y2 is going to be 8 minus y1, which is 3, divided by x2, which is going to be 6, minus x1, which is going to be negative 1. Okay, so 8 minus 3, that's 5. 6 minus negative 1, that is 7. Okay, so the gradient of this line then is 5/7. Okay, now we want the gradient of the tangent though, but we know that the tangent is perpendicular to OA. So the gradient of the tangent, which I'm going to call M2, is going to be minus 1 over M1, isn't it? It's the negative reciprocal. Okay, so we're going to flip that M1 over and we're going to put a minus sign in front of it. So the gradient of the tangent is going to be negative 7/5. All right, so now we've got the gradient of the tangent, and we know a point that it passes through. So we should be able to fill it out now. So we know that the equation of the tangent, it's a straight line, so it's going to be of form y equals mx plus c. And we know m. We know therefore that y equals minus 7/5 of x plus c. Okay? And then we know it passes through the point A. So it passes through A, which has got the coordinate 6, 8. So subbing those values in for y and x. Y is 8, x is 6 at that point. So I'm going to get 8 is equal to minus 7/5, lots of 6 plus c. Okay? Well, that's pretty horrendous, but doable. So what I've got, 8 equals minus 42/5 plus c. So then c is going to be 8 minus, sorry, plus, isn't it? Because it's going to change sides, change signs. So c is going to be 8 plus 42/5. Well, 8 is 40/5. So adding them together, that's going to be 82/5, isn't it? So that's equal to 82/5. I'm just going to leave it as a fraction, I think. So therefore, y is equal to minus 7/5 of x plus 82/5. Okay, now it's not quite in the form that they want yet, because we want it now in the form ax plus by plus c is equal to 0. So multiplying through everything by 5 to first off to tidying it up, I'm going to get 5y is equal to minus 7x plus 82. And then bringing everything to the other side, I'm going to get 7x plus 5y minus 82 is equal to 0, which is in the form that they want. Ax plus by plus c is equal to 0. Question 21. The diagram shows 3 circles, each of radius 4 centimeters. The center of the circles are A, B, and C, such that A, B, and C are a straight line, and AB equals BC equals 4 centimeters. Work out the total area of the 2 shaded regions. Give your answer in terms of pi. Okay. Now, first off, this is a horrendous question. EdExcel have a habit of putting in a very hard question somewhere in their sets of papers. Now, it's worth 5 marks, but you have to bear in mind that most people aren't going to get any of these marks. And if you get any of them at all, then you are kind of above the curve. These sorts of questions are really there to kind of decide between the grade 9 and grade 8 students. If you're not aiming for grade 9 or grade 8, then you wouldn't stress too much about these sort of end questions at the end that are super hard. But obviously, if you can score some points, any points off them at all, then you're moving in the right direction for the grade that you're going to get. I always think they're worth a go, but then again, if you come across something like this at the end of the paper and your mind just goes blank, then I wouldn't stress overly about it. Like I say, this is just a question to decide if students are going to get a grade 8 or a grade 9. It's only really for grade 9 students who should really try and get as many points of this as possible. And also, you can get a grade 9 even if you got 0 on this question, if you did well on all the other questions. Okay, it's a hard question. We're going to give it a go. But yeah, if you encounter one like this in the wild, then just give it a go and don't stress too much if you can't solve it all the way through. That's my advice. But anyway, I'm going to show you the solution. Now, I'm going to get a ruler out and add some more lines in here, because at the moment it's not very clear what's going on. Okay, now we want to find the area of that shaded region. But what is that shaded region, and how does it relate to the circles? I think what I'm going to do is I'm going to add some extra lines on here. Okay, just to give you a bit of a clearer picture of what's going on. Okay, if I draw a line like that, and like that, you can see I've got a triangle. I don't know what sort of triangle it is. Okay, can you think about what sort of triangle this is? Let's start off with there. Let's just have a quick look at that triangle. Now, this line here from A to the edge, that is the radius of the circle, isn't it? Okay, because A is the center and that point up there is on the edge. And so is this. This is another radius. Okay, so those two are the same length. So I could say that that side there is equal to that one. Okay, But also, this side here, look, this is also a radius. It's the radius of b to the edge. Okay, and because all these three circles are the same size, then that means that is the same length as well. So what we've got here is an equilateral triangle. Okay, so that's an equilateral triangle. And I could do the same thing down here as well. If I put another point down here, I could make another equilateral triangle down here. Okay. Now I could do the same over on the other side. I could make two other equilateral triangles over here as well. Draw those in quickly. Okay, so I've got 1, 2, 3, 4. I've got 1, 2, 3, 4 equilateral triangles. Okay, now if I wanted to find the shaded area, in that case then, I could find the area of the circle B, which would be everything inside the circle, and then I would have to subtract those 4 equilateral triangles, and that would give me mostly B, but I've got some extra bits as well that I would then need to subtract as well. I've got like these parts here, haven't I? Like that part there, that part there, that part there, that part there. Now hopefully you can see that all of these are the same size. They're all kind of like a segment on the edge of the circle, okay? And they're all kind of equal to each other. So what I would need to do is I would find to find the shaded area, it's going to be the area of the circle, and it's going to be minus 4 lots of those triangles, isn't it? 4 lots of the equilateral triangle. So I'm going to have to take off 4 of the triangles, and I'm going to have to take off 8 of those segments. Okay, that's what I need to do. So in order to work out the shaded part, I need to work out those 3 things. The area of the circle, which is easy, that's just pi r squared. And then I need to work out the area of one of those triangles and times it by 4. And I need to find the area of one of those segments and times it by 8. And then if I subtract that all away from the circle, I'm going to get the shaded area left. Okay, so that's what we're going to do. We're going to work out the triangle, and we're going to work out that segment, and then we're going to do the subtraction, and then we're going to have the answer. All right, so let's do that in parts then. So let's work out the circle first. Start on a easy thing. Circle area is going to be pi r squared. Okay. So the radius we're told is 4. Okay, so that's going to be pi lots of 4 squared, which is equal to, it's going to be equal to 16 pi. I'm just going to leave it in terms of pi for now. Okay, right, so that's that. Now, what about the triangle? Now, area of a triangle, that is going to be, well, it's an equilateral triangle, isn't it? Which means it has like an angle there of 60. So how can we work out, and I know that the radius is 4, that's 4 and that's 4. So I've got 2 sides and the included angle. So I could use like the trig formula for area to work out the area of that triangle. Do you remember what it is? It's half AB sine C, isn't it? Okay. So what's that then? So that's going to be a half. A and B are just the radius, isn't it? So it's half 4, 4, and then sine 60. Okay. Now this is the non-calculator paper, but luckily sine 60 is one of the angles that you need to know from your table of angles that you should have committed to memory. And I know that sine 60 is just root 3 over 2. Okay. And that's equal to 16 over 2 times root 3 over 2. Okay, so then dividing 2 times 2, 4 into 16, that's going to give me 4 root 3 for the area of the triangle. But what about the area of those green bits then, those areas of their segments? What are we going to do with those? Okay, well, let's have a think about what a segment is. So if you think about it, what I've got is I've got a sector of a circle like this, but then I'm taking a triangle away and it leaves me with the segment, doesn't it? So if I've got like a 60-degree angle here, and I've got a sector, okay, and then I subtract the triangle part, it should leave me with the green part at the end. Does that make sense? So I know how to find the sector of a circle. So an area of a sector, because that's just
minus triangle
over 360
4
times
root
the
3,
area
and
of
then
circle,
therefore
isn't it,
that's
that
the
one?
area of my segment, then,
Okay,
isn't it?
so area of sector is that.
4 root 3.
So
Okay.
I know the angle in the center is 60, so it's 63/60ths of pi times 4
Just
squared.
moving this over a little bit to give myself a bit more room.
There. So that's 1/6
pi over 3
of
minus
pi
the area of
times
the triangle,
4
which we worked
16
out to
pi
be
over
4
6, then,
root
isn't it?
3. Okay.
So that's 16
Right,
pi
now we've got
over
all the
6.
bits.
16 pi over 6, which is the same thing as 8 pi over 3. So the area of the sector is 8 pi over 3. But then, then the area of the segment is going to be then the area of the sector,
Just moving over a little bit to give myself a bit more space, minus the area of the triangle, which was 4 root 3, then gives me the area of the segment. So the area of the segment is 8 pi over 3 minus 4 root 3. Okay. Right, so now we've got all the bits, haven't we? We've got the area of the circle, which we worked out to be 16 pi. We've got the area of the triangle, which we've now worked out to be 4 root 3. And we've got the area of the segment. So we've worked out that to be 8 pi over 3 minus 4 root 3. Okay, so then we just need to string it all together. So now we can say that the shaded area is going to be the 16 pi from the area of the circle, isn't it? Okay, and then minus 4 lots of the area of the triangle, which is 4 root 3. And then we're going to minus 8 lots of the area of the segment, which is 8 pi over 3 minus 4 root 3 then. Okay, and that came from the purply bit over there, didn't it? Okay, that's where all the bits came from. So now it's just a matter of multiplying it all out and tidying it all up, and then hoping we don't drop anything along the way. All right, so I've got 16 pi, nothing to do there. Multiplying out that bracket, 4 lots of 4 root 3, well that's going to be 16 root 3, okay? And then the second bracket, minus 8 lots of 8 pi over 3, that's going to give me minus 64 pi over 3, and minus 8 times minus 4 root 3, that's going to be positive 32 root 3, okay? So you can see now we've got two terms. We've got terms in pi, 16 pi and minus 64 pi, and we got two terms in root 3. I've got minus 16 root 3 and 32 root 3. Now it looks to me like the pi part's going to be negative, so I'm going to write the root 3 parts first. So 32 root 3 minus 16 root 3, well 32 lots of something minus 16 lots of that something is going to give you 16 lots of that something. So that's going to give me 16 root 3 from combining the two green bits together. And then I've got 16 pi minus 64 over 3 lots of pi. Now 16 pi, if you think about it, is 48 over 3 lots of pi. So if I just rewrite this as times that by 3, I'm going to get 48 over 3 lots of pi then, isn't it, as a fraction. And then 48 over 3 subtracts 64 over 3. Going to subtract the numerators, 48 minus 64. They've got a difference of 16, haven't they? So that's going to be minus 16 pi over 3. Okay, so that's the bits I got from the yellow bits there. Okay, so that was quite horrendous. So that was a fairly hefty question, and I doubt that many students would have worked that through to a full solution under exam conditions. I don't reckon many people have done that at all. But, you know, you could have scored marks for parts of it. You know, working out the area of the circle was probably worth a mark. Spotting that it was an equilateral triangle and working the area of that out would be worth marks. So, you know, even if you don't get to a full solution, as long as you're kind of thinking it through, if you manage to think any of part of it through and write any of it down, you know, you might find that you score 2-3 marks on these sorts of questions, even if you can't get it all the way through to a solution. So always worth giving them a go, always worth trying it out, always trying to see if you can break the problem down and do part of it, even if you can't do the whole thing, but not to get too stressed in an exam situation when you come across EdExcel's rock hard question at the end of one of the papers. Okay, what you don't want it to do is let it throw you off your game, you know, because you should really expect there's going to be a tough one at the end at some point in the EdExcel papers. It's because it's what they do. Okay, yeah, and barely anybody's going to get those marks. That's the other thing to remember. But anyway, if you wanted all the marks, that's how you get them.
You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.